Okay, so hi everyone. So this will be a demo on DevOps training. About myself, currently work as a global DevOps lead for a big MNC. In my day-to-day thing, I love to dig into various DevOps problems and solve with modern technologies. My mostly work goes on architecting, creating, and scaling the optimizing DevOps workflow for a large-scale organization and large-scale workflows. Apart from my day-to-day job thing, I also love to talk about DevOps in various tech conferences, webinars, and also the trainings and trainings and various courses like this. So without further ado, let's start of the demo. So first thing, I will start with the scope of the demo. This is introduction to DevOps and introduction to CI/CD. We'll see how this goes in half an hour, but I will try to cover most as much as possible for the demo purpose. So first thing first. So what is basically DevOps basic? What is the introduction? What's mainly the problem is? So there are in the modern world there are lots of teams. One is called Dev, which basically covers your development team, your testing team, which basically makes an application, right? Um, and then there's an Ops team which deploys that particular application made by the dev to a particular servers or live environments, and that's how the whole life cycle of a product goes. But the problem comes when there are two segregation between the two teams, which is dev and ops, and there is no communication, and it's like throwing the ball out of the fence as an application that my job is done as dev and you take care of ops, and there are lots of confusions. So how to solve this problem and make the product as one team to generate more and more business value is basically somehow to merge this dev and ops to work together as a team without any silos. But it this is a very basic thing, and around this whole concept to make team work as a one team without saying that I'm a developer, I'm a tester, I'm a ops, but think about as a product, the whole concept comes as a DevOps. But you probably heard a lots of buzzwords. So you know uh, to be honest, we start with development, operation, and DevOps. There is someone put this name, and the term is bad, is really bad because it started as an agile operations when it in initial days, and then some it turned into DevOps, and by the time everyone realized it was a terrible mistake, it was already established. And now on this term basically you have heard lots of probably heard lots of few other terms also. If it comes about security, it's a DevSecOps, because DevOps is very too exclusive. If you just put business, is a DevBizOps, quality DevQOps, UA DevUAOps. So it's just too exclusive, and in terms of making inclusive we are just increasing the terms. So let's not try to create a new bad term, and let's live with one bad term called DevOps. But let's try to understand the basic principle and concepts what this is and how it can be benefited to any large scale and small scale organizations, as well as an individual who are choosing this path as a career. So we start with an introduction. So suppose um, is a common scenario for any organization, the teams of different work stream used to be on a different part of geography. Like suppose there's a project management team, dev team, QA team, UA team, ops team. This is the general setup which every team or every project have. So suppose this is the example company we have named is Banana Corporation, and it is scattered around the world. Now a requirement comes basically, and it goes via different mode of the team in terms of reading the requirement. So suppose it starts with UA and it goes to dev, then it goes to QA, and then it goes to project management, and then at last it goes to ops. If you see these numbers 1 1 1, so one is basically, it's if you suppose the actual work is estimated for 1 day only, the actual implementation work is 1 day. But due to the lack of different communication and different silos within an organization, it just take too many times. So suppose this 5 days, 5 days, 5 days, and this lead time goes to 25 days. What lead time is basically the time it takes to deliver a feature from when the idea started and when it goes to production. That's called lead time. So the actual work, you see, it was only for say one day for everything, and it actual days it takes more than what we expected, because of the silos. So what's the solution of this? So we have to, and this is the very basic thing, if you want to understand how the toolings and all the technologies behind it, but we have to understand the idea. And the biggest idea is that we have to tear down the silos. So biggest problem in most organization is not within the silos, but between the silos. So what does this mean? Silos is basically, development says that I'm a development team, I don't care about testing. Testing says I don't care about development. Same goes with ops, we don't care about how we deploy. But basically it's, we have to understand that, the problem, acknowledge that there are silos in most of the, organization. And in, for this path, in DevOps path, it is very important to understand that the silos, there is no place for silos. So what's the different part or different best practices to solve it? The first one is, so there is different silos, so create cross functional autonomous teams. You have to, form a team which is basically cross functional, which have all, skills within the team, and that is an autonomous team. All people with a direct impact on product should work in one team. So all people who are developing, who is testing, who is, deploying, should work as one team. And that's what the concept says. Moving on, terms of definition, a very pretty good definition and very short one is, the DevOps is a culture. So we have to understand that DevOps is not about tooling. Yes, the backbone is tooling, but the tooling can only be take place when the organization have this DevOps mindset and the culture, and it is ready to get invested on those paths, and then the tooling comes. So DevOps is a culture where people, regardless of title or background, work together to imagine, develop, deploy, and operate a system. What a system is, it's your product. So everyone is very much, you know uh, just focus on developing a good system, a good product, and everyone work together, and they have a culture, and that this culture is mainly called DevOps. So that's the definition. The tooling part comes later, which we'll cover. But before tooling, this is very important to understand that it's DevOps is not about tooling. If someone asks what is DevOps, it's not about tool. It's a culture where you have to make sure that your organization follows it and have that particular mindset to work together, regardless of what your title or background is. Okay, so we start with very important and very basic things. DevOps, what are the DevOps principle? How, you can, develop a DevOps project, or how you can implement DevOps within your organization or within your team in a large scale, small scale. So the first thing is CALMS, which is called a DevOps principle, also a framework, for assessing, how an organization, I mean, in what form is they are ready to adopt DevOps. Because if your organization is not ready to invest, in the DevOps mindset or DevOps journey, it will not be fruitful to invest in the thing. So there is a thing called CALMS, which is abbreviation of culture, automation, lean, measurement, and sharing. So let's see about those things. Let's start with culture. So what basically change you need in terms of, go on a DevOps journey, the transformation within your organization. So the first one is the culture. You have to change from functional silos to cross-functional teams. You have to include lots of people with a different skill in one team. Heteronomy to autonomy. These teams should have, autonomy to, decide on some things. And the very important thing about, you have to change your mindset about avoid risk and failure as a failing as learning opportunity. Because DevOps says that you have to fail often and fail fast, and that's how, where all the toolings also come, which will be outlined in this course. And the mindset is, you have to fast early, so to increase your business value, increase your develop efficiency, rather than having that mindset like will not take the risk and failure. Never revise policies should be changed to continuous process review. Because DevOps is about, it comes from the agile, and agile comes from the continuous change. You have to be always try to keep getting better in terms of your culture and what the processes you have. The second one is obviously very automation, and there is most of the course outline, concept on this course will be outlined in terms of automation. But after you have this culture, or you probably as a student already have some DevOps implementation in your organization and want to learn, then that's the second and very important part, which is also the backbone, which is automation. So we have to make in mind that however how much we can automate, it will directly proportional to how good your DevOps practices are. So the first one is infrastructure as code. Whatever infrastructure you are creating, it will be a code, which is also, in the course outline, you have Vagrant, you have Ansible, right? So we'll see on those things. The configuration as code, everything should go configuration as code. It is also an Ansible and also Git. Everything should be as code, because you can change code anytime, but and it will be automatic. Then the testing obviously should be automated. There is no room for manual testing in the CI/CD pipelines, which we'll see how we can make it via Jenkins. We have to avoid repetitive tasks. We have to fast, and we have to share and document the knowledge. So automation is a very big backbone for this, DevOps transformation. The third part come as lean. You have to be lean in terms of however you can in terms of your processes. So first, system thinking, how you are designing your system, you should be very lean. Always focus to the customer. Customer is the king, and customer is the key to generate the business value. So whatever you design, you should always think how my solution is going to affect your customer. And again, the fail early, fail often. The early you will fail, the early you will fix the bugs, and more your customer will be happy, and it overall it will more business value for your organization and your project. And the continuous improvement, obviously, it's an it's not like that in one night you learn the toolings and you can implement DevOps. It takes lots of time, it takes processes, lots of reviews, and it's always continuous improvement. There's always room for improvement, so you have to be in this mindset. The fourth one is again is very important, called measurement. So an automation is as good as it is. If you cannot measure it, you cannot say that how good it is, right? So you can only improve what you can measure. So if you're, suppose example, if your automated test, how much tests are passing, if you don't know that, you cannot tell that how your pipeline are performing. So basically measurement builds confidence, it identify the bottlenecks, and measure and use result as input for next improvement cycle. So we have seen that we have to see continuous improvement, and for that measurement is very important. The next one is also very important, the sharing of the responsibility, successes, knowledge within team, between teams, between companies. As I said, DevOps is a journey. So suppose it start with a very small team, and they got success, and then you basically talk to different teams, be a multiplier within your organization, and make your identity and your brand value as a SME on these topics by sharing the things and sharing your knowledge and success. So if you see, this is very popular representation of DevOps. The first one is called, called the symbol of DevOps, where you have every part of a project lifecycle done continuously for a change, starting from plan, then code, build, test, deploy, release, operate, and feedback. All the main motto of DevOps is to get feedback as fast as possible, and all these things backed by the toolings called CI/CD toolings and infrastructure toolings, monitoring toolings, everything. But the main point to understand the DevOps principle comes, which we just saw. Until unless we don't have that mindset, those principles in place for any organization before starting the automation or before going on this journey, it is not going to be successful. So this is a nice representative of all the application lifestyle, how it looks. Moving on, for the demo purpose, I will touch upon introduction to CI and CD. And again, I will not go in detail because that's a demo session, but I will touch some very important pointers which you have to understand before going to automation, and basically understand with automation and with learning of with this course and toolings what eventually you gonna achieve, right? So let's start with the very important part, CI and CD. And CI CD is the backbone of DevOps. DevOps, as we saw, it's basically a culture, not a tooling and all. but the behind the scene, the tooling which works is called CI/CD. So let's see. So this is the classic delivery model where we come from, right? It is a long product definition and development phases. Someone have 6 months of development phases, 3 months of testing, and they release as a big bang. The big bang release is very error prone. It's manual, time consuming, complex, and many involved parties, right? So example, if you see the product opportunity assessment happens, the discovery happens, the planning, development, testing, approval, release, and it basically takes just too much time, right? A value add. So if you see the value added time is 3 days, 1 week, 10 days. So if you see the elapsed time in value added times, we are basically uh, losing lots of time in the classic delivery model. And then people wanted to go fast in the industry. They wanted to release as often as possible to increase the business value for their particular customer, and there comes the CI/CD. So people mostly ask in lots of today's modern world in technology that when should we move to CI/CD, and the answer was yesterday. This is a very hot selling skill as well as for organization as for individual, because with the simple fact that if you're not moving fast, your competitor is moving fast, right? So you are going to go outside the market if you're not releasing fast for your customers. So there is a reality check, or there's a very important Google State of DevOps report which happens every year, called also called DORA, where they measure any DevOps company or any company's DevOps processes success out of on 4 KPIs, which was deployment frequency, lead time, time to restore, change failure rate. We can go into detail in the classes, but for the demo purpose, you can see there are 4 categories: elite, high, medium, and low. So based on your KPI, your current success, and you will be put in a high, medium, or whatever performer you are, and you should always try to do on a light side. And this is also, if you just relate to the DevOps principle of monitoring, right, of measurement. Until you don't measure it, how will you know that what is deployment frequency, and how will you improve to one category to another? So it's all depends on all those principles. Okay, moving on, go to a bit technical terms. So first thing is first, what is continuous integration? So continuous integration is a practice that encourages developers to integrate their code into main branch of a shared repository as early as often. So putting in a very simple term with this figure. So what is continuous integration? Suppose you're a developer, rather than merging your code to your main line from main line, or basically the main release, main branches in your Git, to release in say 6 months, 3 months, you try to merge your code as often as possible, ideally every day. So what it happens, so here a developer, suppose you're a developer is there, and this is a source control. You can take an example of Git, you probably know, or anything, SVN or whatever your organization use. So developer talk to source control via, he changes the code to source control. Once the source control happens, there is a continuous integration system. Example, Jenkins is continuously listening to the source control, and when the developer change anything to say source control, like, hey Git, this is my change, please accept it. Git says, okay, I can only accept if your continuous integration system says that it is fine. And then where Jenkins comes, and Jenkins says to Git, okay, let me test it for you. And basically it build it, test it, and report says, okay, this change is fine to merge. And once this is merged, basically you merge it to mainline in the source control and you release it. And this whole process called continuous integration, it can happen multiple times a day, with multiple developers, all the teams working on a single mainline, to make push the code changes as fast as possible. So this is process called continuous integration, where is a you integrate your code into a main branch every day, instead of building out features in isolation and integrating them at the end of a development cycle. Okay, so that's the definition. We'll see more. The second definition is continuous delivery. So we have shown the continuous integration, basically where you change multiple times in your source, right, source repository. But there is no point to only changing to source repository if you're not delivering to your customer, right? So the CI is the first part, where you basically verify your code changes, that you are what you're Proposing to main is fine, and it is ready to go to the next step. That's called continuous delivery. So it is ability to get changes of all types, including new features, configuration changes, bug fixes, experiments, whatever, into production or into the hands of users safely and quickly in a sustainable way. So what it means, so basically this thing you're seeing is the CI, so design, develop, test, and it comes to release. It goes to continuous delivery processes. There are all again some toolings you can use Jenkins. There are some also different toolings for continuous delivery also. So it goes to customer. But there is also a term called deployment. So you have to understand that deployment is not delivery. So what does this mean? Let's try to decode it. So there's a term called continuous delivery and there's a term called continuous deployment. So continuous integration is the normal thing which you know, and continuous delivery is and continuous deployment is fundamentally the same by how you are, you know, putting your code into your customer or user's hands. But there is only one change or only one difference between delivery and deployment. So whenever you basically moving the code from one phase to one another via CI and one is to deployment, continuous delivery always take manual decision before deploy to production. It could be probably review from your delivery manager or someone like that, until unless an authority says that okay, we are fine to go to production. It stays into the say acceptance test or any user testable environment. And the continuous deployment is like an automation thing. So it and continuous deployment is very mature practices, and very mature companies like Amazon and Netflix do it because their changes are very important for users, and their systems are very mature, and you when you change it, it basically test it in every form and it automatically goes to production. So if it is automatically goes to production without any manual intervention, it's called continuous deployment. But it when it goes to in a manual intervention, it's called continuous delivery. It's based on the business use case, you know, where you want to, what your business use case is. Do you want to provide multiple features to your you know, customers every day, like in Netflix, if they want to say upload a new movie or new link, it's fine, they can do that. But probably not on a say in a ERP system or something like that, right? So based on that, you can choose what CD model you want to choose from. So just to repeat, so in a one single form, so continuous integration is the same, where you build test of each of your changes continuously, and once it is fine, you move to acceptance test, staging, and the production to deploy is manual in continuous delivery. But in continuous deployment, it goes to without any manual intervention to you know, to the production. Just quickly summarize benefits of continuous integration, what you need and what you gain. So your team will need to write automated test. You need a continuous integration server, which is Jenkins is one tool. There are a plethora of toolings for CI like Jenkins, Travis CI, GitHub Reactions, GitHub Actions, Azure DevOps, etc., etc. So developer need to merge their changes as often as possible, at least once a day. That you what you will need to integrate or implement continuous integration within your project. What you'll gain, less bugs get shipped, because if you remember, we heard about fail early as fail often. So less bugs because you are, you know, getting it after your code check-in that okay, this is not working via continuous integration system, and basically you can fix it. There will be less integration issues. Testing costs are reduced because you are testing it quickly, we are testing it early rather than going into say pre-production or acceptance phase. And your QA time spend less time on testing and can focus on significant improvements to go to the quality culture rather than doing the same task, manual task again and again. They can actually do some significant improvements of the quality culture. And just to remind this, CI/CD is not an alternative of quality. Quality is very much important, but at the same time, it provides the, you know, framework and toolings to automate as much as possible and put the good testing minds into improvement of the quality culture within the organization. Benefits of continuous delivery. Again, what you need a strong foundation in CI, because if your CI is not working, your code is not moving from one environment to another, and that's, I mean, you cannot do it, the CD part. Deployments need to be automated. The trigger is still manual, but once a deployment is started, there shouldn't be no human intervention. And what you gain, you can reduce the complexity of deploying software. Your team doesn't have to spend days preparing for release anymore. You probably heard about, we are creating a package and we are releasing it, and it takes 7 to 10 days for releasing a software. So you can release more often and eventually generate more business value for your customer. What's the big bang is small and frequent delivery? What's the difference? So if you see, big changes deployed rarely, the change is there, the time is there. So if it is deployed at the last time, this much amount we have already lost, because you have find the bug here, not here, right? So it's already, that much particular effort is gone, and you have already lost too many dollars, euros, or INRs, whatever your currency is, right? Small changes deployed frequently, they are fast ROI, they are low risk, because there are small changes, we are not waiting for deployment for a big bang kind of thing. It process low risk, fast ROI, and better workload balancing, less stress, because we know that if anything is failing anywhere, it's small. And how these small things gets deployed is via CI/CD tooling, which you'll see later part of the course. So some people do think that small and frequent releases are scary, but it is not. Releasing is hard. Release seldom is drama, but if you just put this culture, releasing is easy, and release often via the CI/CD toolings or the automation you will learn in this course, it is actually easy, with obviously with practice and lots of hard work. So let me show you basically an animation how the developer to customer, and that's what the whole CI/CD and DevOps is, right? To take your code from your development machine to move to the customer environment, and that's where all the toolings automation comes into the picture. So this is the code, and we wanted to generate a value to the customer, right? So this is the, suppose, SAP development environment or any development environment, and there's a production environment, right? How we can do via the continuous delivery and deployment pipeline, where you commit it, you test it via CI, then you integrate it automatically. If you have performance, then you performance, then acceptance, and then production. So basically these things, what you see, these things are called stages, CI/CD stages. If probably you heard it or no, then the amount of your code is touching every part of your life cycle. Every life cycle is called a stage, right? Example, commit, integrate, performance, acceptance, production. This can be changed according to your this is not hard and fast rule, it can be changed according to your business needs, but this is a standard how anyone can deploy. So once you change your code, it goes to the commit phase, then it goes to production, I mean the whole journey how it goes to. And then basically there is a some principle and method to generate this business value, and then we'll see one more animation in a very much detail to illustrate how the CI/CD pipeline works. So some principle: create a repeatable, reliable process for releasing software. And there is some principle: if it hurts, do it more frequently, bring the pain forward, automate everything, keep everything in version control. We see how the Git works, build only once. We can see in the Docker how where the Docker comes into the picture on these things. And you have to understand that done means release. So when you say done, that means your software is released. Okay, let's try a deployment pipeline. So as we said, suppose this is basically a car manufacturing unit. This is mostly the same. So suppose there is a car maker who's basically making a car, and then you have to sell to the customers, right? So just like that, this is our CI/CD pipeline. If you just relate to that, this is our CI part where all the testing happens. I have Jenkins, but you can use any tool. So let's say commit one. Commit means changes. So if you change your code first time, that is called one commit. So suppose source code repository, if you change something in source code repository, you have make the one commit. As if you remember, I said that for every change, Git talk to Jenkins, and Jenkins says, okay, let me test it for you. If tested it, and then the version 1.0 happens, and then basically for this version, for every commit there will be a release candidate. If you just again make the analogy with the car maker, so suppose one car came into the production system, and that particular car is the you know a candidate for selling to the customer. Just like that, a particular change into the code is a release candidate or a feature candidate for the customer to production. And suppose you have run your CI pipelines and suppose unit test or something got failed, and then it will be red. This means your pipeline has stopped, or again in the car making, this car has defect, it cannot go to the customer, please fix it. Then it will basically stop the line. Then until this is not fixed, there will be no code will be pushed, and basically the whole machinery is stopped. And that's how the power is CI/CD. Basically you identify early the bugs and you fix it before going to any expensive and later stages, right? So again, someone developers fixed, okay, you find something is fine in this version, and then he make another change called commit 2, and then the next version is obviously 1.1, and this time it pass in the commit phase and it goes to integration as 1.1. Now integration have some tests in that environment. Again, this is automated for qualifying, but now you find that, oh, something wrong in integration environment. Again, you stop the line because it's still not in the customer hand, and then you do the again commit, and this time commit again start from the beginning, not from integration. You have to make sure whatever you are changing is not generating any regression also. So suppose this time it passed in commit and also pass in integration, it goes to next time to acceptance, but this time it fails in acceptance. What will happen? Again it will go to with a new commit and it start from beginning again, right? So, and this time suppose it passed the acceptance, it goes to production. And that's how the in a visual way the CI/CD works. And behind the scene obviously the toolings are there which we'll learn in this course. So it basically fast feedback and increasing confidence, the CI/CD things, and that's why we do it. The faster feedback, the environment become more production like because you are learning the toolings like Vagrant, Ansible, and creating your environment as code. And the obviously at the end the goal of the continuous delivery is the build quality in faster deployment, faster feedback, better software, and most importantly happier customer. So on this note, this is basically was the introduction and the demo session. We have a big bang course outline lineup starting with the introduction, the virtualization along with Docker. We see how Vagrant works, the cloud computing, the AWS, GCP, what are the GCP, how the Git works, and with add-on topics apart from this outline of the Docker, because this is very important in these modern days. And the course resources, basically it will be the PPTs, PDFs, the web link of references, the sample DevOps engineer resumes will be given. The lab setup is pretty straightforward in terms of all the modern laptops, mostly the preferable on the Mac Linux, but it will also work on the Windows. And for any hyperscaler, say AWS, GCP, will need active accounts on those things. The mock interviews, obviously, it's always good to revisit what we learn in terms of interviews. So there will be some mock interviews, and also the suggestions for different certifications available and very highly rated certification in the DevOps world. But in additional, there's also a course completion certificate from MindMajix, which basically says that you have achieved and you have learned some good things with the DevOps thing, and it is certified from this particular organization. On that note, thank you so much for joining. This was the demo session. Looking forward to meet you again. Thank you so much.